We're going to now flip it around. Instead of me giving you the general term and asking for the values, I'm going to give you the values and ask for the general term. So here we go. Oh, I need a new slide. That's nice. Determine the general term for the given sequence. I think you can actually quasi-read this a little bit easier than when I use a white, dry erase marker. It's like 10% better. That's weird. Okay. We'll do the first one together. I'll give you like 3 more to try on your own. Part A. Suppose you had 1/2, 1/4, 1/8, 1/16, ... A trick to doing these is maybe rewriting the terms, because you're allowed to, and try to see if you can get a 1, 2, 3, 4, 5, so on. And then once you do establish a 1, 2, 3, 4, 5, then replace that with an n, and then you're done. So for instance, 1/2 is the same thing as 1 over 2 to the first. 1/4 is the same thing as 1 over 2 squared. 1/8 is 1 over 2 cubed. 1/16 is 1 over 2 to the fourth. So the denominators are powers of 2, not multiples, they're powers of 2. So what do you think the general term is for this one? Don't say 1 over 2n, that implies a product. 1 over 2 to the n. There you go. Sure. So this is the same thing as 2 to the negative n. You could also say 1/2 raised to the n. So there's a whole mess of answers. Any of them are acceptable. All right, so the trick is rewrite it, try to see if you can get a 1, 2, 3, 4, so on. And then replace that 1, 2, 3, 4 with the n. I'll write up a couple more. I'll take a nap over there real quick. I'll be right back. All right, so part B, similar to part A, but 2, 4, 6, 8 are not powers of 2. What are they? Multiples of 2. So what would your general term be? 1 over 2n. Because this is 1 over 2 times 1, 2 times 2, 2 times 3, 2 times 4, so on and so forth. Part C, notice that the signs alternate. Whenever you see an alternating sequence, that means you have to have a negative 1 to a power. You'd have 2 choices, really. You can have a negative 1 to the n, or you can have a negative 1 to the n plus 1. There's no other reason to have anything else because this covers it, meaning this says the first term, the odd terms would alternate, would be negative. This says the even terms would be negative. Did I say that right? Yeah, I said that right. So for this one, which of these two should we use? The first one. All right. So this guy takes care of the odd terms being negative. But now focusing on everything else, 4, 16, 64, 256, what do they have in common? They're powers of 4. So this is really 4 to the first, 4 to the second, 4 to the third, 4 to the fourth, so on and so forth. So what are we going to multiply this negative 1 to the n to by, I should say? Yeah. So you could write this as one term, negative 4 raised to the n power. Either of these are acceptable. And then there is part D. No, you can't ignore a term. It's like ignoring a child. You can't ignore children. They're our future. So we need a term, so when we plug in 1, we get 2 over 1. So it was intentional that I did not write that as 2. So 2 over 1 is 2. But I purposely wrote it as 2 over 1. So n over n minus 1 quantity squared. We can't do this because a sequence has to start at 1. Right, so this is not the right general term because we can't cause a division by 0. And we wouldn't get 2 over 1 as our first term. What do you have? N plus 1 over n squared? There it is. Yes. So when we plug in 1 in the numerator, we get 2. Downstairs, we get 1, because 1 squared. Plug in 2 into the numerator, we get 3. Downstairs, we get 4. So notice all the denominators are perfect squares. That's why you should be thinking about squares. 1 squared, 2 squared, 3 squared, 4 squared. And then the numerator is the denominator, the original n plus 1. So this would be the correct thing. So again, this would be 1 plus 1 over 1 squared, 2 plus 1 over 2 squared, 3 plus 1 over 3 squared, so on and so forth. Hooray. It may be some cases where there's a pattern between the numbers. Like in this one, we kept multiplying by a half. That's going to be a certain type of sequence that we'll do in 11.3. This one we kept multiplying by negative 4. Again, the same type of sequence. However, B and C, no. Some students try to figure out, well, if I add a number, if I take half of a half, that'd be a fourth, but a half of a fourth is not a sixth. Things like that. Or they say, oh, if I subtract something here, I'll get the next number. That is a specific type of sequence, but B and D are not that type of sequence. So again, rewrite it in such a way where you can see a 1, 2, 3, 4, 5, so on, and then replace that with your n.